Okay. So what I want to start off with is let's do, I do want to review an example like this before we jump in. So graph, here's the function f of x is equal to, where's that paper? Just want to make sure I write down the right thing. All right, 8x minus 2x squared. Now I didn't do a direct example like this, and it's actually a little bit easier, but students sometimes are not sure what to do because it looks a little bit different, okay? So the first thing we want to do with this problem is rearrange it. Remember, we're used to looking at quadratics in like this, ax squared plus bx plus c, okay? So let's put that x squared term first, and it is a -2 in front of it, and then plus 8x. Okay. All right, so now to get my vertex, I want it to be in this form. F of x is equal to a times x minus h squared plus k, and I'm going to complete the square, okay? So first step, group your first two terms together. Well, honestly, those are the only two terms we have. Okay, in this case, your c is really plus 0. But why write plus 0? It's just not there. Okay, so this is where I said, like, sometimes students are like, what do I do? You do what you've been doing. It's just you're actually less complication. All right, then what do we do next? What do you think?
Divide b by 2.
Yeah, I'm going to do complete the square though. So I'm going to, actually before you do that, I have to review that way. You might be able to do it that way, but I'm going to factor out this -2. I want a 1x squared in front, okay? Then we're going to take this middle term, this -4, divide by 2, and then square it. So this is -2 squared, which is 4. And then I'm going to add 4 and subtract 4 inside, okay? Now, once we do that, we want to kick out that -4. But realize it's not just a -4, it's times -2. So this is going to be times -2. So my function is going to be -2, and then what is x squared minus 4x plus 4 factored as?
X minus 2 squared.
Yes. And then I have plus 8. So this tells me, go away. This tells me my vertex, which is 2, 8. And then what about this parabola? Is it going to open up or down?
Down.
Yeah, it opens down because a is -2, okay? Now, the other part is the intercepts. So let's do intercepts. So for the x-intercept, y is 0, and for the y-intercept, x is 0. So let's see, that means 0 is equal to 8x minus 2x squared. And then this is f of 0 is 8 times 0 minus 2 0 squared. And that's nice because everything just comes out 0. So it's 0, 0. Then here, I'm going to factor. Now, there's no C term, so it's not like a guess and check. All I have to do is look for a common factor, right? So this is negative 2x. We can, if it makes you feel a little more comfortable, we can reverse this, okay? So negative 2x times x minus 4. Let me just double check. That's negative 2x squared plus 8x, yes. All right, once it's factored, I get my two little equations. Divide by negative 2 and x is 0. Add 4 and x is 4. So I get 0, comma 0, and then 4, comma 0. All right, any questions on how we got the vertex or intercepts or any of that? Okay, so in my graph, let's graph it now. I have, this is my x and y intercept, and then I have 1, 2, 3, 4. There's my x-intercepts. My vertex was 2, 8. So 2, this is not gonna be enough room. 2, 4, 3, 4, 5, 6, 7, 8. So it's actually gonna be up here. Okay, so my parabola is gonna come up, peak at the vertex, and then down. And a couple of things to notice, your homework's going to ask you, the online stuff especially, this right here, what is this called? Anybody know?
Axis of symmetry.
Yes. So the online homework makes a big deal out of this. And I mean, I don't know how often we really talk about it, but this is your axis of symmetry. It goes right through your vertex. It's a vertical line. And if you want to name it, it's x equals 2. Okay, it's the line that would be your axis of symmetry. The other thing I want to point out is that this is the maximum output of the function. Okay, I haven't really talked about that. So that means when x is 2, your maximum output is 8. So there's going to be no y value higher than 8 for that function. So we're going to talk about max and min a little bit more, but I just want to point that out. Any questions about graphing that? All right, so I want you guys to do this one. Graph labeling your vertex and intercepts. Okay, we're going to do f of x is equal to x squared minus, minus 2x minus 8. So I'm going to give you guys a few minutes to do this one on your own, okay? Nice little practice. Okay, I'm going to slowly go through the steps of completing the square. Stop me if you have any questions. Okay, so if you did the vertex correctly, you should have gotten 1, -9. Any questions on that? All right, now intercepts. Let me just ask, did anybody finish this yet? Should I do this, or are you guys still working on that? Hello?
I got -8 for the y-intercept and then -2, 0 and 4, 0 for the x.
Okay, that sounds good. Thank you. Thank you very much for saying that. All right, so x-intercept, I'll just run through it real quick. We're going to set this whole thing equal to 0. So x squared minus 2x minus 8 equal to 0. Factors like x minus 4, x plus 2. And then x minus 4 equals 0. Was that Joanne?
Yeah.
Thank you, Joanne. All right, so, and then on this one, y is 0 squared minus 2 times 0 minus 8. So y is -8. So yeah, 0, -8. And then this one is x is 4, x is -2. So 4, 0 and -2, 0. Okay. So let's graph this. Oops. I like the nice straight. Yeah, I like that. All right. So let's see. 1, 2, 3, 4. 1, 2. Which okay. 1, 2. I don't think I can extend it. I'm just gonna have to draw it. All right, so for my intercepts, I have 4, 0, 1, 2, 3, 4, this one, -2, 0 over here. Y-intercept 0, -8. And then my vertex is 1, -9, which is like right here. So I did make this really big. All right, so my parabola is going to start over here, come through my x-intercept, come through the y-intercept, go through the vertex, and then back up like that. Wow, that did a good job, you guys. My drawing is not always as good as people who've had me before. You guys have seen this semester. All right, so here's my vertex. I don't know why I was writing vertex. 1, -9. Now in this case, how is the vertex different from the last one? This is not a maximum. We would call this a minimum, okay? So here my vertex is a minimum. And my minimum output is y equals -9. So if you're asked what is your minimum output or what is your minimum value, they mean the y coordinate of the vertex, okay? And that's -9. And then you have your axis of symmetry. I'm not going to label it on here because I want to use this again in a little bit. But if you're asked your axis of symmetry, it occurs at what vertical line? X equals what? 1, right? So it would go through here. Everybody see? I'm just highlighting it because you're going to get asked that a lot in your homework, and but it's not really a huge deal to me. All right, any questions? All right, so now what we're going to do is go into section 8.9. And 8.9 is it's solving nonlinear inequalities. And guys, I'm going to tell you today is a lot of information, some of which may be new. So if you're used to kind of checking out or dividing your attention during lecture, today is not the day for that. So please, please, please give this your undivided attention, because this is probably one of the hardest concepts in the whole course. Students, and you'll use this again. Here's the other thing. You're going to use this again in pre-calc and calculus. It's going to come up a lot, okay? So let's look at, first of all, what is the difference between linear and nonlinear inequalities? I don't want you to have to spend a lot of time like thinking, is this linear? Okay. You want to be able to recognize it like that. Okay. So here we go. Here's some examples of linear inequalities. Okay, ones we've already done. X is greater than 4. Okay, X is greater than 4. That's a linear inequality. Here's one that's a little more complicated. -2x plus 4 is less than or equal to 8. Okay, what do you notice about these? What are some things that should stand out to you that make it linear?
Your highest power is 1.
Yes. So the highest power on X is 1. There's something else too, but we'll get to that in a minute. There's a second thing that makes it linear. So let's just solve this, okay? I'm going to solve it in a minute. Let me show you nonlinear first. Okay, so nonlinear. If I have x squared minus 2x plus 8 greater than 0, okay? It has a higher power than 1. That's x squared. So this is a quadratic. It's not linear. The graph of this would look like a parabola, okay? Here's another one. 1 minus x over x plus 5 less than or equal to 8. Now, in this one, my powers are 1. But what is different about this versus the other side of this line? What's different about this one?
Is the division?
It's the division. And in particular, it has a variable in the denominator. Okay, that makes it nonlinear. This is a rational function. Its graph is going to be some kind of curve, not a line. Okay, when you get into pre-calc, you will learn how to graph those. At this stage, we're just going to deal with it. Yeah, Andrew, go ahead.
Is it a variable that makes it nonlinear, or just the fact that it's division, period?
That's a great question. So my third example over here was going to be 1 minus x over a -5 greater than 3. Now, if you look on the left side, see how there's a fraction, but the number in the denominator is a number, okay? That's linear. It's when there's a variable in the denominator that makes it nonlinear, okay? The other thing that makes it nonlinear is if you have some kind of weird symbol in like this, like square root of x plus 4 greater than 0. Okay? Roots are nonlinear. Roots with variables inside. Okay? So just recognizing when something is linear versus nonlinear is half the battle. Okay? Now, for linear inequalities, we know how to solve these. We've done this all semester. Okay? The only thing is you have to be careful about is when you're multiplying or dividing by a negative. So when I subtract 4, I get -2x is less than or equal to 4, divide by -2, but that flips my inequality here, okay? So you go right at it when you have a linear inequality. Solving a nonlinear inequality requires a new tool. Okay, so we're going to do something new, and it's called create a sign chart. Sign charts. Okay. Now sign charts are just I'm going to define that in a minute here, but sign charts are let me define that for you. So what is a sign chart? Definition. A sign chart of a function records the signs of the function's outputs or y values. So when the outputs, so it records the signs of the functions or outputs. It tells you where the outputs are positive or negative. Okay, tells you where the outputs are positive or negative. So we know pretty well how to graph like a quadratic, but there's a lot of other functions like these other ones. We haven't spent a lot of time graphing. I told you we're not even going to do number 2 until you get to pre-calc. And number 3, it's not hard to graph, but it would take some time. The point is that the sign chart allows you to figure the answers out to these without having to graph it, okay? So it records the signs of the functions, the outputs, or the y values, what's happening with this function. So let's look at, I'm going to go back. I want to go back to this. I'm going to copy and paste this function. If I can. Yeah. Okay. Copy. paste. I actually want to shrink this down a little bit. It's a little bit big. All right, so I lost some of my stuff in the copy and paste. So let's fill this back in. Here's my x-axis. And then here is my y-axis. Okay, so this was the function f of x is equal to x squared minus 2x minus 8, okay? So what I'm gonna do is we're gonna start by looking at this visually so you can understand what this information is really telling us, okay? So down here, I'm gonna put my sign chart. And what it really is it's like a replica of the x-axis, okay? And so everything that's on the x-axis or that happens at the x-axis has to go on our sign chart. So the only things we have happening are these intercepts here. So I'm just gonna put them here. This is -2 and 4. And these are called the zeros of the function. They're each the zeros. So the first thing I want to note is 1, the x-intercepts are the zeros of the function. And it's the place, remember, that's the place where your graph crosses the x-axis. So that means something has to happen at those zeros. Either, like in this graph, the graph is going to cross over from above to below, and sometimes it doesn't. Sometimes it stays below, sometimes it stays above. But in this case, if I look at everything, if I look at this line before, okay, you realize those are all the outputs that, all the points that are happening before -2, and all the outputs that are happening after 4. What are the values of the y? The y coordinates are going to be what in that part of the graph?
Positive.
They're positive, okay? They're positive because they're above the x-axis, okay? So the y values are positive on these intervals. Okay? The y values are positive. So on my sign chart, what that means is this interval from -∞ to -2 and from 4 to 0, all of my outputs are positive. And technically here too. Okay, so then what happens between these two? Well, between -2 and 4, all my y values are below the x-axis, so the y's, the outputs, are negative. So I'm going to label that interval from -2 to 4 as negative or below. Does that make sense? Do you guys see how that the graph translates to me just labeling them on a like a number line? Okay. Okay. I'm looking again at the values, at the positive and negatives of the y coordinates, but the intervals are actually the x values. So the sign chart tells me which intervals of x values have positive outputs, positive y's, and negative y's values. Okay. Any questions about that? Now, let's look at just this sign chart, and I'm going to ask you some questions. So questions Here's one. For my function, for f of x is equal to x squared minus 2x minus 8, 1. Solve. 1. When is the function x squared minus 2x minus 8 greater than 0? Okay, so this is a inequality. Now we're looking at this in terms of an inequality. It's the same function, but I've set it up as an inequality. It's nonlinear, so I can't just solve it like I would, isolating x, or even a quadratic. We can't even solve it that way. And I'll say more about that, why you can't, tomorrow. I just kind of want to get you exposed to the process. Tomorrow I'll go into a little more detail on why we can't just like do what we did with the linear ones. Okay, so what we see here is, where is this positive? So this is asking, so here's the question. When will the outputs be positive? What do you guys think? Anybody want to take a guess? What would we put?
When it's like less than -2 or greater than 4?
Yes, okay. Now, don't forget, we're going to use our interval notation here. So that interval starts with negative infinity and goes to -2. Would I include -2?
Yes.
Okay, why do you say yes? Because why not?
Because so the value is still 0 and 0 is not negative.
Yeah, there's nothing wrong with 0 itself. And sometimes you do include it, but look at my inequality symbol.
It's not a greater than or equal to. It's just, it has
Yeah.
to be greater than 0.
Right. So it's the problem is in my question here. So since it's not equal to, so we don't include the zeros. So zeros are not included. Okay. So that's a little bit of tricky spot right there. Now, I'm going to union it with this other interval from 4 to infinity. Oops, that was a little crooked. Okay. So just by looking at the sign chart, I can answer when it's greater than 0. And that's asking, again, when will the outputs be positive? Any questions about that, how we got that? All right, here's another inequality we could ask ourselves. When will my outputs, let's do less than or equal to 0. Okay. Now I've included the zeros. What interval would we list here?
Would it just be bracket -2 for bracket?
Yes. Very good. Okay, that would be this part of the interval that you see that's green. Okay, from -2 to 4. Those are all the y values that are going to, if I plug them in my function, if I pick any x value between -2 and 4, I'm going to get outputs that are negative. Okay, let's just test some of these numbers. Okay, I know you can see it graphically, but let's just test some numbers. Let's see if this is really true. And I'm going to test, let's pick some from each interval. So I'm going to pick -3, because that is over here, right? Here's -3. I don't want it to keep it there. Give me a number between -2 and 4. Any number.
-3.
Between -2 and 4.
1.
1. Yep. And then 1 greater than 4. A number greater than 4.
6.
6. Okay, good. Now, if I put in x equals -3 into my function here, x squared minus 2x minus 8. I should expect my output to be what? Positive or negative? According to this.
Positive.
Should be positive. Okay, let's just check that. So f of -3 is -3 squared minus 2 times -3 minus 8, which is 9 plus 6 minus 8, which is 15 minus 8, which is 7. So it is positive, as we expected. Okay, let's do x is 1. F of x, I'm sorry, f of 1 is 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8. -1 minus 8. That's -9. Oh, that's the vertex. So yeah, negative as expected. Okay, and then let's just try x is 6. So f of 6 is 6 squared minus 2 times 6 minus 8 equals 36 minus 12 minus 8, 24 minus 8, which is 16, positive. Okay, so that confirmed what we already knew. So -3 is going to have an output of 7. So wow, that's really kind of far up here. It's going to be like up here. 1, -9 was down there in the negative region. And then 6, the output was 16. Holy cow. Okay, so, well, I mean, these things shoot up really fast. So, you know, it's up here somewhere. Any questions? Everybody see how all this information is coming together?
What happens when the parabola is just all above the positive or all below the negative?
That's a good question. Let's look at that. Before I do my next graph. So what if your parabola was all up here? What would my sign chart look like then?
All positive?
Yeah, I don't even have any zeros to put on there. It would just be positive. Because your outputs are always going to be positive, right? And it doesn't even cross the x-axis. And then if I had, like, say, this, it would be all negative with nothing else on the sign chart. So I have a feeling you're not going to get those too often because they're pretty boring. It only gets exciting if it crosses the x-axis. Okay. All right, let's look at this example. And we're going to pick something that is not a parabola. Because remember, nonlinear is not restricted to just parabolas. Let's look at something like this. If I have a cubic, okay? So construct a sign chart for the function g of x is equal to x cubed minus 7x squared plus 15x plus 9. Okay, this would take a lot to graph. I'm going to give it to you in its factored form. It does factor, it's the same. If we were to factor this, it's x minus 1 times x minus 3 squared. Okay. Now, I don't care about, I'm just going to give you the graph. Okay. All right, so just looking at this, by the way, you should kind of notice your zeros are going to be at 1 and 3, your x values. Because if we set this equal to 0, you would just get these equations. Okay, everybody see? So that the factored form gives us our zeros. So that's where it's crossing the x-axis. And then if I plugged in 0, I could get your y-intercept. And I'm just gonna give it to you. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's actually right here. And you could, if we plugged in again, so this is my x-intercept, just to show you I'm not just pulling these out of the air. I would plug in 0. So it'd be -1 times -3 times -3, which is -1 times a +9, which is -9. Okay, so if we have the factored form of something, we can at least get the intercepts. That makes it nice. Okay, now the way this graph is coming from below up through that. And it does something like this. I don't like how that looks. Okay. Everybody see the graph? Now, just looking at this, I'm going to construct my sign chart. Again, it's the x-axis, so we have to put our zeros on there. So that's 1 and 3. And I'm just going to label them with a Z because that tells me those are the zeros. Okay. Now, what is happening before 1? What are my input or my outputs? The outputs, the Y values.
Negative.
They're negative. Okay. How do you know? It's below the x-axis. Okay. This is all negative. If I pick any point on here, like if I pick this point, I don't know, it looks like it's 0.8 comma -1. Okay. My outputs all along here are all going to be negative. Okay. Now, what happens after? Between 1 and 3. Now my graph is up here. What are my outputs?
Positive.
Positive. And then it touches again at 3, but it's still positive. Okay, so here's an example of a graph that does not just alternate. Okay, you have a region with negative outputs, then positive again. Any questions on how we just looked at the graph and figured that out? All right, so here's a couple of questions to ask you. 1, solve g of x is less than or equal to 0. And I'm just, remember, g of x is this. Okay, so I'm not writing that whole thing out, but that's the function. And I don't need to look at the graph anymore. I'm just going to look at the sign chart. Okay, where is this less than or equal to 0?
-infinity to 1.
Yeah, -infinity to 1. Do I include 1?
Yeah.
Yes. How do we know? Because it's greater than or equal. This includes the zeros. Okay. All right. Solve this. When is my function greater than 0?
One to infinity.
Okay, 1 to infinity. But because it's not equal to, we have to be very careful. I'm going to start with 1, okay, because that's this right here, but I can't include my zeros. So I'm going to have 2 distinct intervals here, and from 3 to infinity. Now, if I had this, if I had g of x is greater than or equal to 0, then we could say from 1 to infinity, because that 3 would be included. Okay, you guys see the difference there? So that equal thing, it can mess up your intervals if you're not paying attention carefully. Any questions? Okay, I'm going to stop recording here.